Welcome back for some more straight fire math. Here we are at episode 20 involving volume. And all these questions here are, I believe, are involving looking not for the volume necessarily, but looking for missing dimensions or missing measurements in the shapes that we're given. So as with everything, try to do these questions yourself. Pause the video and read over what the question's about, try to solve them on your own, and then use me as a guide to help connect the dots if you're not able to, or just to check your work. So pause the video and then unpause when you're ready. All right, in this question here, Tracy has two empty cube-shaped containers. She's filling this one with water, dumping it into the other, which will not fill the cube completely, but it will just fill it up to a certain mark. And they want to know how deep that measurement will be. So with all these volume questions, it is important that you pinpoint the right formulas that you're going to need. For a cube is a rectangular prism, and in any prism we can use the formula volume equals big B times H. Now big B is the area of the base, and in this case the base is our squares. So length times width is a way to calculate big B. So we could use big B times H, which in this case would be length times width times height. So how much water is in the first container? Well, it's a cube, and in a cube, all three dimensions, length, width, and height, are all the same. So it would be 5 times 5 times 5, or 125 cubic inches. Now that one's getting poured into this cube right here, and we're going to use the same formula, volume equals length times width times height. But this is no longer a cube because it's not filled all the way. This is just a rectangular prism. So it does not have squares on all surfaces. It has some rectangles. It's got a square base. So in this particular case, we do know the volume of the water that's inside. We just calculated it. The volume was 125. The length is 7. The width is 7. And the height is something we don't know. So it's just 125 equals 49x. And then we're going to have to round. So we're not expecting to get a whole number answer out of this. So we've got 125 divided by 49. Comes out to be about 2.55. It says to the nearest tenth of an inch. So 2.55 would turn into just 2.6 for x. All right, and we've got similar mysteries here on the rest of the page with different shapes. So for question number 2, we're talking about a pyramid with a square base. The formula I'll need for the pyramid is given to you on the exam is 1/3 big B times H. So we've got a square base, which I'll draw slanted like that. And we know that it has a length of 18, so it must have a width of 18. And we're looking for how tall it is from the tip to the base. So we're looking for the height. So since we're talking about a pyramid that has a square base, big B would again just be length times width. But because it's a pyramid, it would be 1/3 length times width times height. Plugging in what we know, 756 for the volume, 1/3. Length times width would be 18 times 18. And the height is what we're solving for. So if we did 18 times 18 divided by 3, we have 108. So 756 equals 108 times h. Divide by 108. It comes out to be exactly 7 centimeters tall. Let's take a look at these other ones. And again, pause the video. If you should pause the video to try these on your own. So for number 3, once you're ready to go, this is what I did for 3. Determine the radius of the cylinder. Well, you have to use the right formula for it. The volume of a cylinder is pi r squared times h. Again, it's a big B times the h. The bases, though, are circles. So the area formula for the bases is going to be pi r squared. So we're looking for the radius. We know the height. And we know the volume. So the volume is equal to pi times the radius, which we don't know, squared, times the height, which they're telling us is worth 14. So all we have to do is get r squared alone, and we're going to have to do some rounding as well. So you can do this in one big step. Divide both sides by pi, and divide both sides by 14. If you're going to do it in one big step, make sure you put parentheses around the 14 and the pi. If you do all that, you'll get r squared by itself. But on the left-hand side, you'll get a pretty crazy looking number. It'll be an irrational number, so don't expect a nice clean-cut answer here on the left-hand side. So just as I expected, and maybe you did too, you end up getting 2.9557, and of course the decimal goes on forever and never repeats itself in a predictable way. So you just have to square root that answer, and you end up getting that the radius is about 1 point. This is rounded to the nearest inch, so 1.71. So rounded to the nearest inch would put the radius at about 2. And looking at the last question, it says the volume of a sphere is 1,500 cubic centimeters, and we're looking for the diameter. All right, so gotta make sure I'm geared up with the right formula. So a sphere is a ball or a globe, and we're looking for the diameter. But there's a formula for the volume of a sphere, and that's given to you on the exam as 4/3 pi r cubed. So placing in the numbers that I know, 1,500 is equal to 4/3 pi times r to the 3rd power. Just as in the last question, we can get r squared by itself pretty quickly if we divide both sides by 4/3 and also divide both sides by pi. I would even do that in 2 separate steps just to make sure that you don't make a mistake with the calculator. The 4/3 will cancel, the pi's will cancel, and all you have left is r to the 3rd power. So I'm going to dial that in, 1,500 divided by 4/3. I put the 4/3 in parentheses as I divide it. That gives me 1125. And then I'm going to divide that by pi. So my r squared, my r to the 3rd power comes out to be around 358.098. So it's about 358.1. I'm not going to round yet. I'm rounding it there just so I don't have to write the entire calculator display, but I'm going to take the answer that I've got on my calculator, and I'm going to get rid of the third power by doing a cube root on the calculator. Square rooting gets rid of squaring. Cube rooting gets rid of cubing. So I'll have r all by itself. I have to dial this into the calculator. This gives me a radius that's about 7.1. I'm not going to round just yet because I'm not done finding my answer. They're asking me for the diameter, so I'm going to have to multiply this answer by 2 because the radius is 1/2 of the diameter. So as it turns out, then the diameter would be 14.2, which says round to the nearest centimeter, so 14 would be the answer that we're looking for the diameter. Alright, so that gave you a good variety of questions to look at for volume, and just keep on working hard to the end of the year. If you're following this video series in order, you're seeing that this pretty much matches what probably the sequence that most math teachers use throughout the year. Keep on working really hard, do your very best, and we'll see you next time with episode 21, which might be the end of the series. So remember, you can always use these videos again to replay or to look at the end of the year to sharpen up. You might be using this just for review. Tell your friends about it. If you like the videos, you can give me a thumbs up. It doesn't make a difference to me if you like them or you don't like them, but it's always nice to see that people are commenting on the work that I'm doing. So have a great day.